Welcome to the 19th video in the Metric Math Water Wastewater YouTube series. This video is going to help you figure out how many liters of one solution needs to be added to how many liters of a second solution to form a specific volume of a specific concentration in a solution. So here's a visual picture of what we're going to be trying to solve in today's example. Notice we need to make 175 liters of a specific solution, 9.2%. Now we're going to add to that 13% solution of unknown volume. That's what we're trying to find. We're going to water that down. We're going to dilute that with a 4% solution. But again, we don't know how many liters of that. Now, if we look at just the basic information, we can do a bit of a guesstimate. If we take a look at 13 solution and a 4% solution, halfway between that, if you calculate halfway, that's about 8.5%. But we need a 9.2% solution. So just that basic information alone can tell us that we're going to need a little bit more of the 13% solution and a little bit less of the 4% solution, because 9.2 that we need, our target, is a little bit higher than the average. So right off the top, we can guesstimate the 13% is going to be higher volume than the 4%. Now, looking at the information that you see here, what are the key words? Well, starting off, what's the percentage of the concentrated solution? We identified that already, 13%. What's the percentage of the weak solution? We already identified that, 4%. What's the target? Well, the needed volume is 175 liters, and the needed concentration is 9.2. Now remember, we know already that because our target 9.2 is higher than halfway between 13 and 4%, which would be 8.5, we know that we're going to need more of the 13% solution and less of the 4% solution. Well, let's find out exactly how much we need. Now, what's the highest concentration? Well, it's 13%. What's the least solution concentration? It's the 4%. What's our target? 9.2%. Now this is kind of like a picture way of making a solution. You could solve it with X's and Y's and stuff like that, but this is a relatively simple process. First of all, you take the large concentration minus the 9.2, and that works out to a difference of about 3.8. Now we're not going to put a percentage value in, we're just going to put 3.8. What's the target? Minus the low, or 9.2 minus 4, that works out to approximately 5.2. You add those two together, and it works out to be about 9.0. So notice right here, the number for 5.2 associated with the 13% is bigger than the 3.8 associated with the 4%. So again, we know that we're going to need more of the 13% and less of the 4%. Now, the solution that we use to solve. First of all, we connect that 13% with the 5.2, and that gives us a little bit of a fraction. So we know 5.2 out of the 9 multiplied by the target volume of 175 will give us 101.1 liters of the 13% solution. Likewise, the low number, 3.8, is connected with that 4%. So 3.8 divided by 9, the total, times 175 gives us 73.9 liters of the 4% solution. That all totals up to 175 liters. I hope that this simple little solution method will help you if you're trying to solve these types of questions. Now let's do a quick little review. We needed 175 liters of the 9.2% solution, and we had two solutions to add into it. One was 13%, and we added 101 liters of that. And then we added, of the 4% solution, we added 73.9 liters. And notice how 13% was a little bit higher than the 4%, 101.1 liters compared to 73.9. And that resulted in our final solution, 9.2%, was higher than midway between the 13 and 4%. So that confirmed what we were trying to estimate. Thanks for watching this math video. Please check out the other videos in this channel. Put in some comments and pass this site on to other water or wastewater students who might be struggling with the same type of question. Goodbye for now, and have a good day.